Good afternoon, everyone. It's my pleasure today to introduce Mr. Garrett Campbell to our weekly colloquium. Mr. Campbell is a senior software engineer at Microsoft. He has contributed to the C++ developer experience in Visual Studio and in VS Code. He has made contributions or key contributions with Microsoft, supporting embedded developers in VS Code, such as the serial monitor, and supporting C++ developers who use the CMake or Makefile build system. Recently, Mr. Campbell has played a key role in integrating AI into C++ developer tools as AI continues to impact developer workflows. He has worked to develop tools to improve build performance, integrating existing build performance tracing capabilities with AI. These are all timely contributions. And I should have mentioned this from the start. He's an ECE alum, 2021 ECE alum, so we are proud of him. And so without further ado, we are all very excited to hear what you have to say, Mr. Campbell.
Thank you. Thank you. Yeah, as you said, Garrett Campbell. I work for Microsoft, a senior software engineer. And yeah, hopefully I'll give you something that you can take away from today and learn a little bit. So the main topic of this is continuously learning, adapting, and improving, with kind of a focus on my journey, and then specifically AI's impact on developer workflows and tools, as he stated, kind of the things I've been focused on working on at Microsoft. So the overall agenda is go a little bit of my background and experience, some hobbies and things that I'm interested in as well. Embracing learning. Hopefully I can at least impart some sort of knowledge about things to keep in mind while you're learning and some tips and tricks. Going over the changing landscape. And so one kind of visual to think about this is in 2021, when I graduated, the world felt a lot more simple, or at least what we think about with traditional development. At least it feels like I'm too young to say traditional development. But you've got Visual Studio, VS Code, you got your command line interface, and then you've got your build system. This is the CMake icon, for those who are not aware. This one here on the right. And then GitHub, and it felt like you had a pretty simple workflow. You worked in your IDE, you pushed code, you pushed it up to your source control in Git, and then you had your CI/CD pipelines and things like that to do testing and building. But now, in the present day, we've got a bunch of different things that totally look different in the landscape of AI. So you've got Copilot CLI up at the top. You've got the Copilot chat in Visual Studio here, ChatGPT, the Model Context Protocol, which we'll talk about later, and then that's the Copilot logo. And so just kind of an image into what has changed over the past couple of years and how AI continues to make an impact. And then lastly, we'll go over some reflections. So a little bit about who I am, some places that I called home. I grew up in Augusta County, Virginia. I expect that none of you will really know much about that, but if you know where JMU or UVA is, we're about equidistant to those two. And then I lived in Blacksburg, of course, VirginiaTech, and then I've lived in Redmond and in Washington, Washington and Charlotte. I'm also a VirginiaTech grad, graduated in 2021, major in computer engineering with a focus in software systems, and then I minored in computer science, and so that actually worked out for me because I think when you think of Microsoft and working on that stuff, it's definitely more computer science than it is computer engineering. And then I was also an ECE ambassador and various other things. I also got the pleasure of being able to graduate right at the tail end of COVID. So 6 feet apart, of course, with the masks on, but I was able to graduate in person. So that was good news. And then I'm also a Christian. I go to Wayside Baptist Church locally back at home. So if you're ever in town, feel free to reach out. We can go to church together. And then I'm also a pet owner. These are some pictures of my rebellious pets. This is Owen in the top right corner, and then this is Kubota, the new addition in the past year to the family. Some hobbies and interests that I'm in. I want to talk a little bit about this just because life is not all about work and all of our tech and all the things that we care about. It's also about some of your interests and stuff. So I'm really big into fitness. This is a picture of the top two are me in some Spartan races. So that one's in the Poconos, the top right. And then the left is in Jacksonville, Florida. And then this is actually a picture of me and my wife, Caitlin, who, for those in the room today, she's over here. You can wave if you'd like. But this is also the Disney Princess Half Marathon down in Florida. So we had fun racing in that. I actually matched with my wife there. So that was kind of fun. And then also I'm into coaching. I hear a little bit of an echo, by the way. But that's fine. So I help coach. This is actually a couple of pictures of me at my local high school that I actually attended when I was there. So I helped coach the varsity and JV football teams. And then additionally, sports, you'll catch us at pretty much all the football games that we can make. We have season tickets. We'll be at spring game this upcoming weekend. So if you're there, come check it out. And then additionally, some more kind of tech-related hobbies. So I've recently gotten really big into 3D printing. I actually have a brother-in-law who we call Frog, and so I figured that'd probably be a great thing to start with. And then my wife's rule for buying a 3D printer was that the first thing I make was for her. So there's a vase that actually ended up not holding water, but that's beside the point. And then this is actually my wife's family business, Stanton Tractor. So that was the first custom one that I made, where I made a coaster with that logo on it. And then some recent things I've started, a personal blog where I've got the first one being the smart garage door opener. I'd always wanted to kind of build my own. And so I built my own garage door opener. Most of it is custom, and then wrote a blog about it. And then there's some upcoming project ideas. So a little bit about me, some of the things I like to do kind of off to the side. But kind of more about my technical background and experience. And so I've worked in multiple different industries. I've interned in hardware manufacturing and government contracting. I actually worked at Innovative Defense Technologies, which is right here in Arlington, as an intern, and then Microsoft Developer Tools, which is what I'm currently in. And this has kind of allowed me to learn a lot of different technologies, tools, frameworks, all the things you might think of, and then also learning how to learn, which is kind of the thing we'll talk about at the beginning, of how to prototype and how to not necessarily let yourself get bogged down with the fear and the various things that come up as you're trying to learn new things. Some more specifics and timelines about my experiences in 2019 is when I interned at IDT, working on various kind of each weapon systems and things like that, simulations. And then from then on, it's been Microsoft. So interned in 2020. I got the blessing of the opportunity to actually intern at the same team that I now work at. So that made the transition into full-time work a lot easier. And then I kind of buried the lead there. But now 2021, Microsoft, until present day. I'm actually 2 months away, I believe, from 5 years. So as a quick kind of intro snapshot to my work at Microsoft, we're going to talk a little bit more about what I've worked on in a second, but this is a quick demo of where you can actually see in VS Code some of the features I've worked on and some of the things I've been the most proud of. And so you can actually see here on the left, as this thing starts, the CMake tools project view. And so you can see a bunch of information about your CMake project. But then what I really am proud of, I kind of built this thing from the ground up, is the serial monitor. The thing that it's actually reading the output of is actually from a test version of my garage door opener. So you can see all kinds of stuff that I added in there. But these are kind of two of the main features that I'm really proud of, as well as all the other stuff that I've worked on. So kind of just an intro into all the work I've done. When I was an intern, I worked on Visual Studio Linux tool checking, kind of a complicated name, basically making sure that whenever you connect to your remote machines through Visual Studio, you've got the tools you need. Then, as I just kind of showed a quick demo of the VS Code, and actually it exists in Visual Studio as well, the serial monitor extension. And I don't say this to brag, but this is one thing I'm really proud of, is we've got 30,000 monthly users, and it was just really cool to be able to build something that genuinely started at zero. And now it's got a lot of users that hopefully are happy with the experience. And then CMake support, this is in both Visual Studio and in VS Code, and some data on that. Similarly, the CMake is one build system, Makefile is another. And so we also support a Makefile tools extension. And the primary purpose of this one is to provide IntelliSense and help the developer have a good experience in VS Code. So that way you don't have to just kind of guess at what you should be editing. And then most recently, Visual Studio Build Insights. And this provides information to build performance hotspots. And so ways that you can make your build a lot faster and therefore your inner loop a lot quicker, make your data life a lot easier. And that ties right into kind of the AI sort of things where we integrate with Copilot to be able to not only help you work faster and more proficiently, but also help the agent or whatever Copilot chat you might be working with, help you work more speedily. So embracing learning, kind of the first main section of this is why does continuous learning matter, and kind of going into various topics about that. And so first, let's focus on specifically continuous, and that's kind of the main theme of why continuous learning matters, not just learning as a whole. And so first, the kind of broad reasons is why it matters. Is it keeps you relevant. Things are always changing, and it boosts confidence. I think also I've found that it's less about what you know at any given point, but your ability and maybe just as importantly, your willingness to learn and be able to adapt to different situations. Also, the pace of change. I think we all can say, or at least already know, that technology industry is always changing, especially in this new AI world. Things are happening at a really rapid pace. And so you're not going to be an expert about everything all the time. And that's just kind of the nature of the job. And then also just a quick, simple strategy is just always be ready to learn. Don't simply solve problems, learn something new to help you solve more. And like I said, I think with AI, this can be especially prevalent because there's always something new to learn that can help you become even more proficient at whatever you're working on. But now we'll really dive into that word continuous. And so a lot of these slides coming up next, I have the reference here. It's going to be from Atomic Habits, a book by James Clear. And he talks a lot about different strategies and different things to keep in mind for how to learn and how to best use this. And so this is a graphic directly from the book. And so it talks about how being 1% better every day can really show great gains and make a huge effect on your life. So 1% decline, you can actually see here that it's not quite as exponential, but the idea is that you will slowly and slowly get worse and worse or not progress in whatever it is that you'd like to. But 1% improvement every single day has a 37x throughout the end of the year. So I just think this is it was really impactful for me when I read the book. And I think it's really important to keep in mind because it's something that seems so simple, but it really can be 1%, which can be an infinitesimally small feeling progress, but over time, over a year, that'll make a huge impact. To kind of go off of that, one visual that it used was the amount of effort and work that you're putting into, or in this case, the metaphor is that temperature is putting onto this cube of ice, can be really impactful. And so, but you might not always see it right away. So here you've got this visual of an ice cube melting, or at least not melting at the beginning, as you go from 26 to 27, 28, 29, 30, and so forth. And you can see that all this effort that the temperature, in this case, is putting into the ice cube, it's not actually coming to any fruition. You're not actually seeing any output of that. And so it can feel like you're wasting a lot of time. But the second that you hit 32 or 33, starts to melt, and then you feel like, I'm finally making progress. But really, continuous effort is making a difference even when you don't see it. And so all the progress and work that you put in at the beginning is what got you to that point. But during the moment or during that time where the ice cube wasn't melting, it doesn't feel like that. And so to kind of come off of this, the book coined, I think I'm giving credit to the book for coining this term. It's possible that it was around beforehand, but the plateau of latent potential. So this kind of put words to that metaphor that we just talked about. And so here you can kind of see, I think we've all probably been aware of how people say progress, we wish it was a straight line. And so what you think should happen versus what actually happens in this valley of disappointment that you kind of end up in. And I think we really kind of can combine these two into something really powerful of remembering that we can acknowledge the fact that this valley of disappointment is going to happen. But as long as we keep that 1% continuous improvement every day, you can look back and realize like, oh, wait, I did hit that inflection point where the ice started melting. And I did end up having from the 2 slides ago, I think 37x improvement over a year. And you can look back and say, oh, wow, I did make some impact on my learning. A quote from the book directly was, complaining about not achieving success despite working hard is like complaining about an ice cube not melting when you heated it from 25 to 31 degrees. Your work was not wasted. It is just being stored. I just thought that was a really impactful thing to keep in mind, especially in a space where things are changing all the time. I'll be quick in this slide, but just a couple additional quotes that I thought were really cool to keep in mind. Winners and losers have the same goals. And this was talking about how we shouldn't always be primarily goal-oriented, but rather process and habit-oriented. And this goes along with the 1% of learning every day. Because as it says, you can imagine someone who's trying to win the Super Bowl or teams who are trying to do that. The loser also had the same goal of winning the Super Bowl. But that doesn't mean that the processes and habits he created didn't have a huge impact. And then similarly, your identity emerges out of your habits. Every action is a vote for the type of person you wish to become. This was really impactful. I felt like it really hit the nail on the head of how much we tend to kind of treat ourselves and look at ourselves with our identity based on what we're currently doing and based on like an example it gave was of a smoker. Like it's really hard to break that identity, but really every action, every time you wake up and do 1% of learning, you're actually casting a vote towards an identity that you want to have, and therefore having that identity. And then it goes over some strategies, some habit stacking, environment design, and starting small. And I just thought this was really impactful to keep in mind as we continue to get into a faster and faster paced world with technology. And so it's important to keep these things in mind when it comes to learning. Additionally, to kind of go into how this has affected my career specifically, one big reason why continuous learning matters is that your knowledge base will expand. And so now we'll go a little bit into embracing learning in my career. So you'll notice, hopefully, that this slide looks a lot like one of the slides that we looked at earlier when I was talking about the different features and things that I've worked on. And so first, some tools I learned when working on Linux tool checking was things like C#. Most of Visual Studio and a lot of Microsoft code is in C#. Linux distributions, Visual Studio ecosystem. Visual Studio is a big project or product, lots of source code to be had there. The serial monitor, learning a lot about embedded systems, actually getting to work on a lot of stuff that came from computer engineering, which was really fun. Various debugging methodologies and processes, so JTAG, SWD. Hopefully a lot of this is unfamiliar to you because it was to me. CMake support and VS Code, so things like TypeScript, working in VS Code extensions, that ecosystem. Similarly for Makefile, as well as the Make build system. I hadn't been exposed to that before working on this feature. Visual Studio Build Insights, this was probably the biggest switch back into like really focusing on the compiler and things that are really low level in C++. So working on Windows performance analyzers, how to do event tracing in Windows, and then obviously the big AI, Copilot with AI, Python, Azure AI, working with AI systems. And so I think the big thing I wanted to notate here is that almost none of this, except C++ and some of this embedded stuff, did I learn while I was at college. Being in the ECE department, you learn a lot of stuff, but you don't necessarily learn C#. You don't inherently learn a lot of these different things because that's product specific. And so kind of taking some of the things that we learned from the Atomic Habits book, a lot of stuff that you learn on the fly, and so being able to be flexible and learn on the fly is really important. And so, as I stated, over time, your knowledge will grow exponentially. So these are kind of the different buckets that I went over in the past slide with the features of the different kind of new things that I've learned over the past couple of years. So you've got build systems, the CMake and Makefile. You've got how to integrate with all kinds of different features and product surfaces. So you've got the different APIs that I use, VS Code extensions, then getting as low level as Windows APIs to be able to do performance analysis. And then a big one that I think is not often learned while you're at school is the CI/CD and compliance side of things. So being able to have continuous integration, running pipelines to automate tests and builds, and then compliance tools to make sure that you're following whatever compliance rules that you have to depending on your product, as well as AI tooling that we'll get into as well. A couple specific, I guess, fields of struggles that I feel like I often have in my career when it comes to learning is wanting to understand the entire world, wanting to build the entire world, and then, of course, I feel like we all have this at times, imposter syndrome. And so first, I think that it's really easy to struggle with wanting to understand the entire world, especially coming from college straight into the industry. So for example, in my intern project, the goal was to understand what tools were on the Linux system that the user needed and did not have yet. But I just joined the team. I'm getting exposed to this massive code base. It was kind of difficult to basically compartmentalize and say, okay, what exactly do I need to know versus wanting to understand this entire system and all the complexities that it has. And so more recently, with AI, how can I build something, for example, that I don't understand all the ins and outs of how a model was trained, how the interfaces work, what side effects the APIs might have. And so getting discouraged, it was really easy for me to get discouraged from just trying it out, understanding what I could understand, but then trying it out and going for it. Additionally, wanting to build the entire world. And so this is very similar, setting unrealistic expectations, but it's very similar to wanting to understand, but different. I found myself really wanting to and putting high expectations on myself of, let's build this thing and let's do it fast. Let's do it in a week. Let's do it in a day. And that's just not a realistic expectation. And so this is also something that's easy to fall into because of how much you see people online, Instagram, Facebook, YouTube, all the different places where you see a short clip into the thing they built or the thing that a company created. And you'd like to convince yourself that that happened quickly, when really that might be years in the making. So give yourself a little grace there. And so one example is the garage door opener project that I worked on. It was really easy to try to bite off more than I could chew. My original goal was to build everything from scratch, build a home server, build the sensors and the embedded pieces that I'd need to actually sense the door opening, all that, and build it all. But my hope is that this all of a sudden is a big splash of information and feels like a lot. I realized that's a big system to create by myself. So first, you've got to do the hardware. You've got to figure out what actual pieces you want to use, how you want to integrate it. Hopefully, as you continue to look at this, it does get simplified because it's not incredibly complex. But trying to do all of this in a week, which was my original goal, was crazy. And so this was one thing that I've had to battle when it comes to learning and progressing my career. And basically taking each piece at a time. The state diagram of how it would work. This is a screenshot from Home Assistant, a popular open source home automation, which is a hint there. I gave up on writing my own server from scratch. But yeah, so this is just one other kind of way that I struggle sometimes with learning. And then lastly, imposter syndrome. I think we all have this issue sometimes, but setting unrealistic expectations. So I know for me more recently, like getting the title of senior, it's really easy to think like, oh, I should know everything. Like if someone asks me a question and I have to say I don't know, like that's bad. But really, that's just the nature of the beast. That's how everybody learns. And so one other thing that comes into play here is comparison is the thief of joy. So I work with a lot of super smart people, and it's really easy to compare myself to them, even if they're 10 years farther into their career, and things like that. And so imposter syndrome is a battle that I think we all have, but it's something that's really important to keep in mind and contextualize in your brain. So a couple of overall lessons learned. First is to dig deeper. Don't always just, in my world, like fix a bug or fix a feature and just call it a day. Make sure you understand not only the reason it happened, but then maybe learn an extra piece, write documentation, build something else that helped you solve that issue, and kind of take it one step further. Also, humility and curiosity. Even experts sometimes meet surprises and have things they don't know. You can always learn something from someone. Give yourself grace. I think especially with the slide I talked about, building it all in a day or building it all in a world, like sometimes learning takes time, and it's really hard to give yourself that grace, but I think it's important. And lastly, learn with the intent to teach. I think this is really important. It's really easy in kind of today's consumerism world to just want to consume, watch YouTube videos, just learn. But if you learn with the intent to teach, you can not only solidify your own understanding, but you help build the community around you and help share that information. So now we'll kind of jump more into the technical part and talk about the changing landscape and how AI is specifically accelerating and modifying and changing everyday developer tools. So first, kind of a quick overview slide is just that there's a rapid evolution in artificial intelligence. I think that's an obvious statement for a lot of us, but this is just a quick overview of just how fast and how much more crunched recently the timeline has gotten. So in 2015, OpenAI is founded, and then 2020. But then that's a 5-year gap. And then as we get to these dates here on the right, it's every year. And then if I were to spend more time building a more tight timeline, it would get to every month, every week, et cetera. And so things are more rapidly improving than really ever before, specifically when it comes to AI. But we should not let ourselves get too wrapped up into the hype, because this is not the first of its kind when it comes to this AI revolution, if you will. So there's all kinds of different revolutions that have happened as well that really rapidly changed and continually changed the not only software industry, but the industry beyond. So you've got high-level languages when PCs were introduced. The internet age obviously had a huge impact, and now everything is based into that. Mobile devices, so this is one that might honestly affect us the most when it comes to everything we've got on our phones, app stores for mobile applications, and then also cloud development, and this had a huge impact on developer workflow, probably the closest to kind of the inner loop and how AI has affected it when it comes to continuous integration and continuous delivery. But now we'll get specific into how it's transforming developer tools. Quick credit to a colleague, Ben McMorrin. He did a CPPCon talk about the kind of the real specifics about the model context protocols. If you want to check that out as well, he goes a little bit deeper than maybe I will. But yeah, we'll dive into how specifically developer tools have been affected. So first, and one kind of note for people who are looking at the slides, I have a timeline down at the bottom so you can track kind of the time that we'll be going. So if I forget to say the date of each slide, just check there for that. So November 2022, this is when ChatGPT roughly first came out. And so it was kind of a simple chat. And so from a developer workflow point of view, this would look like me if I wanted to solve a problem or ask something from a coding perspective. You'd basically just have to copy everything into the chat view. So you'd open ChatGPT, you'd say, how can I refactor this code, something like that. And then you'd have to physically copy your code into this chat interface. And so it would look something like this. And so you've got your chat on the left and the LLM on your right, and the user would type, help me refactor this code. You can imagine they'd then paste their code into that chat view, and it would go off to the LLM. It does its thing, generates a response, and then it comes back to the user. Sorry, not the user. It'd actually come back to the chat and then display the response to the user. But then in early 2023, this is when new APIs from OpenAI came out, and so it allowed a lot more product integration. And so this is where IDEs really started to take advantage of these APIs and build these into their products. And so this is actually a screenshot from Visual Studio. You'll notice it's a little different than what the ChatGPT stuff looked like. But this is where IDE integration started and really kind of took hold. And additionally, with these new APIs, it allowed for additional context. And so as you can imagine, an IDE has a lot more context than just, opening a chat app, because it already has that built in. It's already got your build system. It already knows what project you're working with. You can assume it has a workspace open or something like that. And so you can actually use this pound reference. So it can say, help me refactor this code. And now instead of copying your code directly in, you can actually directly reference this context. So how does this change what that timeline looks like? So first, you'd have the same exact initial prompt with a slight more simple step for the user anyway. You'd type, help me refactor this code, hashtag, and then reference the file. But now, instead of going straight to the LLM, it actually goes to the context provider, which in this case is Visual Studio, the IDE. And it collects the file contents, comes back to the chat, makes a final prompt, and then does the same stuff as before, generates a prompt, or generates the response, and then displays that response. So, but how can this be better? How do IDEs maybe progress this? So then comes an automatic context. This is often referred to as RAG, Retrieval Augmented Generation. And so this is, again, a screenshot of Visual Studio. And you can see now that the user did not have to do anything except for saying, help me refactor this code. And the IDE was able to automatically insert this reference of main.cpp, which is now its context. And so, again, how does this look? And so IDEs had a couple options here. You could imagine the IDE also being able to kind of just generate this list of context themselves and deciding how to use that. But they actually are utilizing LLMs to make this decision. So you have the user typing, help me refactor this code, and then you actually ask the LLM what context would help with this problem. And so now the LLM can respond and say, generate its response of what it should grab. The context provider collects the provided context, and then we kind of do the same loop again, go to the LLM and respond it back to the user. And so already you can kind of see how it's gotten easier on the user to be able to just ask questions and get automatic context. But then tool calling and agents came into play. This is in late 2024 and 2025. And this is where it really starts to take off. And so this is actually a screenshot, a little bit of a hint that's a demo I'll give later. But basically this is where tool calling, where you can actually invoke out tools, starts to come into play. But first, we kind of have to make a definition here. What is a tool in the kind of AI space when it comes to developer tools? Tools provide information or actions. So these are external things that you can provide that do those two things. And this is a quick example of what the schema would look like for a tool. So you can imagine the IDEs have these things defined so that the model can determine when to call them. And so this is just a quick example of defining something that can create a PR for you. And so a pull request, that is. And so you can push to the current branch. It gives a description. It gives it some definition of properties or parameters that it can be passed. And then it can also define which parameters are required and which may be optional. And now this kind of creates a whole new world and a whole new flow where, in this example, going with the PR, a user can type, create a PR titled, new PR gives it some title. And then now the LLM has been trained on how to handle these tool calls. And so it actually can specifically be trained on how to tokenize this response. So that way the provider, that the chat in this case, can understand and read so that it knows how to and what tool to call out to. So now it can respond with its first response as well as the tool calls saying created a PR. And then with that special token sequence, it can define this tool like saying create the PR tool with this parameter. And so now the tool provider, which is kind of this new entry in our flow, it can execute the requested action and then return result to the chat. And so you can imagine it says PR created or some additional context, maybe a link. And now the chat will generate the final prompt, and it will actually return back to the LLM again with the special token sequence saying the tool response, PR has been created. And then again, the flow now is at the same point again. The LLM generates the final response and displays it to the user with the chat. And a little bit more generic way to view this without kind of the more specific examples is the user types help refactor the code, creates the token sequences inside the response to get the tool provider. While this is happening, you'll notice as we test especially or use this in Visual Studio, VS Code, any of your kind of providers of this, it'll have tool progress. And then the flow is the same at the end. You pin the final tool results, send that token sequence off to the LLM, and then the chat will display this. But can this be made any better? So now we've got this way that we've given it arms and legs. We've given it the ability to do different actions and stuff that already feels like it's made a big leap because now it doesn't just respond to me with information when I ask the chat something about my code. I can actually have it do something and run a tool, whether that's in the cloud or locally. But can this be made better? And so now you can actually start to kind of expose yourself to the idea of agents and where we kind of can pump this loop. You see this arrow here on the right. And now instead of generating a final prompt and just displaying it to the user, this can actually become a loop where we're actually continually invoking the LLM and being able to run tool calls and do various things. And that's where you kind of start this idea of agents and being able to run multiple things. But now I've kind of spoken specifically in the context of IDEs, so Visual Studio, VS Code, Copilot CLI later on. But what if you wanted to implement your own? So Visual Studio, like the IDE hoster, if you will, can definitely create their own tools. But what if you wanted to expose tools that then it can use that it didn't actually create? And so this is when the model context protocol comes into play. And so you've got this chat interface, which in this case will be things like Visual Studio, VS Code, command line, things that we've talked about. But then you've got different tool providers, and this can be a lot of different things, but the examples we'll talk about are build systems. For example, maybe I want to provide a tool that can build our code. Source control, like the example I gave of creating a PR, and then the cloud. You can imagine different tools depending on your workflow, wanting to control virtual machines, control any kind of resources that you have in the cloud. And so this is when the creation of the model context protocol happened, because you can imagine if all three of these different now MCP clients created their own interface and created their own way to talk, this would be a nightmare, because then you'd have to create all these different versions as a tool provider to be able to support these different platforms. But instead, we can talk through the model context protocol, and I forgot to mention the date, in November 2024, so that these all can talk to each other and be interchangeable of what chat provider you're using or MCP client. And at this point, I'll make a quick reference to Ben's talk again. There's a bunch more you can get into about the specifics of how this MCP protocol works. So all the different parameters, all the different protocol endpoints and things you can talk about. So you can go to his talk for more. There's also the MCP specification I linked. And then some cool concepts that we didn't talk about are elicitation and sampling. And these separately are different ways to, within a tool call, either invoke more information from the user or actually send another request to the LLM to get information. So I'll actually point out, if I can remember, during one of our demos, an example of elicitation. But then we've got these agents. We've got this kind of loop where it can kind of do a bunch of things on our behalf as long as we approve it and give it permission. And it can kind of continue throughout this. But now, how can we control this more specifically? And so now this is where we get into this agentic customization topic, and how you can kind of control what the agent or what the model and the things that it's doing and how it's doing them. So first, we've got on the far left, we'll go from left to right, and this is in mid to late 2025. You've got copilot instructions.md. I'll also mention that a lot of this is based on VS Code, but a lot of these are also supported in things like Copilot CLI, and some are supported in Visual Studio. But Copilot instructions is one way that you can have a per workspace file, workspace meaning just a folder you're working in. And it can do, or it is mainly designed for architectural patterns, coding styles, various things. So you can imagine while your agent, or while the chat view, whatever you want to view it as, is editing your code, you can make sure it's customized in that way. Then there's kind of a offshoot of that, star.instructions.md. And this is where you can do things that are specific to different files or different places in your work stream. This allows you to do, for example, test-based instructions versus production-based instructions. You might have different ways that you want to have code conventions, different ways and stylistic ways that you could write code, and you want it to be able to respect that and honor that. I gave a quick example of the metadata that you would define in the top of your MD file. MD is Markdown, such that you can describe what it actually applies to, so that way it can be filtered to whatever files are important. Then you've got agents.md. This is very similar to this original instructions file, but it's specifically useful when you're using different agents in your experience. So in this case, you can think of agents being like a testing agent, where it's focused especially and prompted especially for when you're working on tests or things like that, or just your regular Copilot agent that you open up in the chat view. Then you've got Claude.md. This is very similar. It's Claude's main instruction file, and it's typically a general instruction file. It holds a lot of your information there. And then you've got star.agent.md. This is primarily supported in VS Code. And this is where you can define, or Copilot CLI, I believe. And you can define a custom agent, and this will actually give you multiple more control points to control your tools, what MCP servers are available, what MCP tools are available, and more. So I gave another example of the metadata that you can give. You'll notice that there's an additional thing called handoffs. I won't get too much into that, but this is where you can define how different agents handoff work to each other. So again, in the example of a testing agent versus just your general source code editing, you can imagine it wanting to control the flow of information, and therefore you can give it a handoff. So this is all kind of more workspace based, and all of these different types of files depend, as long as this one's a little bit more unique because it applies to specific files. But for each request that it gets sent off to the LLM, whether that's through your tool calls or whether that's through your own chat interface, these get sent with every single request. But there's another way to customize your agent that doesn't have that kind of specific behavior. So first, it's the skill.md. And so there's a way to define different skills that your agent can use. And this is kind of another way to provide it with a tool or a way to do actions, but in a more prompt type of way where you just give it instructions in a text file. And so this is meant to be loaded on demand. And so this is where it kind of differs from being sent with every request. So instead of giving it this general instruction of, hey, when you edit test code, make sure you edit it with the style, you can actually do something like customizing how a PR gets created. So in the same way that you have a tool that can create the PR and reach out and do the API call, this can customize how that PR gets created, because this skill gets loaded on demand when the AI determines that that's what you're doing. Also, if you're interested, this is a public repo with all kinds of skills that you can use. And then additionally, you've got prompt files. And so this star.prompt.md. And basically, this is a simplified way to, again, make it easier for the user. So instead of having to, for example, whenever you're scaffolding tests or creating a PR, or those are kind of the two main examples that I can think of, but there's plenty. You find yourself typing the same thing in the chat every single time. You can use a / command to basically reference these prompt files, and that way it gets injected automatically. Kind of another way that the IDE can provide context retrieval for you on the fly. So this is kind of the main ways that things have gotten adjusted and kind of changed as time has gone on. But this also opens the world to kind of fully autonomous agents and assistants, things that you might have heard of that have kind of taken the internet by storm, at least. And so you've got ClaudeBot. It has now, probably for licensing reasons, turned into Moltbot, Copilot Cowork, and Claude Cowork. I won't go too much into this, but the things I've talked about so far are kind of what has made this possible. This is kind of in a world where you really give the agent all kinds of access. So you can imagine access to tools that can read your emails, send emails, do all kinds of things. And this is where you can really let an agent kind of exist on its own, always running, and send requests to it. And it can use all the things we've talked about: additional context, automatic context retrieval, tool calls, etc., to kind of do a bunch of fancy things for you without having to monitor it. If you're interested in that, super cool, but I'm not going to go into too much detail on that. Kind of jumping back into the timeline in January 2026 of specifically developer tools, not necessarily just autonomous agents doing their own thing. The question might have come up when we were thinking about the MCP tools and how to provide actions of, what if we want UI integration for tools? And so what do I mean by this? As a user, when I'm doing things in the chat and I notice, oh, it asks for permission to run some tool, like creating a PR, like doing an analysis, something like that. What if I want to be able to see more information than just a response from the LLM, which isn't the raw data, it's actually just a summarized piece of information? Well, that's where in January 2026, MCP apps came into play. And this is actually kind of an adaptation of the MCP tool. And so this is kind of two different ways that we can go. First, you've got the MCP tool. This is using the TypeScript MCP API. And so this is where you can register your tool. And so again, you've got your name, your description. And also, I didn't mention it explicitly, but this description is really important when you define your tool, because this is the only bit of information that gets passed to the LLM when it decides whether it should call certain tools. So these descriptions can actually get kind of long. Like, you wouldn't just say creates PRs. You'd want to be more descriptive, so that way the model can be able to know when it should get invoked. And then, of course, I got this Lambda function here for its actual action. It'd be a pretty useless tool, but anyways. Then we've got MCP apps. And so this is the same definition, the same API, but now you can pass additional metadata where it actually points to a URI, and it can actually pass it strict or like raw HTML or JavaScript and be able to display information. And this is actually really more important for the user. And so we're still providing that information that can be passed to the LLM for additional context. But now, while it's being invoked, the user can actually see more information. And so full disclosure, I haven't myself played too much with testing out this kind of experience and building my own MCP apps, but this is a quick screenshot of a demo from the VS Code documentation, which I've again linked here. And this is a quick example of like a performance profiler. And so you can imagine, you ask, why is performance so slow? Maybe you're talking about your build, maybe you're talking about your application while it's actually running. And so you can see here at the bottom, it says stuff like database operations took 42% of time, all this specific data. And so that would all be information that could be easily retrieved from the MCP tool, where you just return information that the agent can then use to kind of do work on your behalf. But as a user, you might have a couple of questions. You might have, well, is this legit? Like, is that actually what was returned? You know, we have our own doubts about sometimes AI hallucinating and things like that, as well as just wanting to be able to visualize it yourself. And so then this is where the MCP app part comes into play, and it can render specific HTML and JavaScript to be able to actually display to the user and let the user be able to see what's going on. So pretty cool. And then lastly, we've got MCP plugins. And so this is kind of the last thing on the timeline that I'll talk about. This is in March of 2026, just a couple months ago. And this is a way, specifically in VS Code, I believe support will be coming in Copilot CLI, where you can actually bundle all this information, as well as a couple of additional things that I didn't talk about, into one easy to install thing, like I said, specifically in VS Code right now. But you can define skills, agents, scripts, MCP JSON. So this MCP JSON will help you define your MCP servers. And then you've also got hooks.json. There's a couple things here that I didn't explicitly talk about. So scripts are things that you can either reference via your skills directly. So you can imagine in your skill file, you actually reference scripts that should be ran because it's easier to do it programmatically. And then hooks are ways that you can actually define in certain points within the agentic kind of life cycle. So you can imagine right when the user asks a question, I want you to first save the state of the repository or stash something in your Git. And at the very end, I want you to do a certain thing. So that's where you can define that. Again, I won't go into too much detail on all the different ins and outs of that. And then again, I wanted to link some places where you can try out some of these things. Some of these, this one on the bottom is specific for plugins as a whole. And then the one at the top talks about different instruction files, agents, and skills. And so now we'll go into just a couple of different demos of specifically things I've worked on in the Copilot kind of world, specifically within the developer tools that I work on at Microsoft, and how I've kind of applied the different workflows and work in MCP support within stuff that I work on. So first is the GitHub Copilot build performance for Windows. And so this screenshot is not actually the feature, but I wanted to give a baseline of kind of understanding of what the Build Insights tool provides. So this is actually a screenshot from Visual Studio of Build Insights. You can run this on any build within Visual Studio, C++, of course. And basically, it's got different tabs, but in the included files tab, it basically gives you a window into your build performance, file by file, include by include. So you can see here, this is somewhat of a contrived example because as you can see, this build is only 2 seconds. So we probably wouldn't worry about spending much time on this one. But imagine it's 200 or et cetera, et cetera. And so you can see, normally if I was looking at this and it's a bigger project, I'd look at this first one and say, wow, 55%. Like, I really should investigate that. And so this is the data that we can now extract into a tool that we can then provide information to the agent. And so now I'll give a quick demo. I'll give a quick credit to Eve, one of my colleagues, for this specific demo. But yeah, so this is actually SuperTux. This is an open source repository. You can actually go find where we contributed some improvements to their build if you're interested. But a quick demo. So you can see down here in the bottom right corner, it says @build_perf_cpp. That's the name of our responder or our agent. Help me improve the build performance. And so this will actually start this kind of flow that I talked about and timeline that I talked about earlier. It was super fast. I'm going to try and, oh, no, I'm not. It's going to be too difficult. But basically, one way of elicitation that I talked about earlier that I wouldn't go into too much detail, it actually asks the user for permission first before it builds. And so you actually have to confirm that. But you can see that it actually ran the analysis, and you can see the data that it got returned here saying the 5 different files that it should specifically focus on because they take a large portion of the build. And then it goes around, makes a different optimization plan. It does a typical thing that Copilot Chat or ChatGPT does to make improvements. So you can see some changes here that were made. And then it actually runs the build analysis again. So you can see that it invoked our build performance tool a second time to be able to analyze what kind of improvements it had. And in this case, we actually found an improvement of 69% faster. So it's pretty cool. We've had a lot of different successes with this, but this is just a quick example of that timeline we talked about earlier, where it can invoke tools and be able to really, specifically for build performance, elevate a user who might not be the best at investigating build performance issues. Now you can get a lot of different information from these tools that we already have in the product, but now within the AI context. Additionally, this is an example of the CMake build and test tools. So I gave a super quick example of the CMake tools extension at the very beginning. I mentioned it on the left side, that's just a status view. But now I'll give an example of some of the things we've added within the AI kind of sphere. And so specifically, we've added build and test tools that help you build and test your code. And so this one is actually an example, a video from my manager, Ian. And you'll see he's got a code base open, a bunch of tests on the left, and then on the right, act like you didn't see that. Where's my mouse? There she is. Okay, so first you'll see it's really small text, so I'll read a bunch of it. But basically the idea here is that he's trying to add a bunch of tests to this code, and he wants to make sure that not only after he adds the test, the code still builds, and then he'd also love to go ahead and run the tests. He doesn't want to have to take the time to run them himself. And so we start this off, he sends this off, and then it'll be hard to see, but keep your eyes here on this output. And then in the chat view, you'll see that eventually it makes the changes in his test, it adds the test, and then it calls out to our CMake tools build and test tools. And so it actually runs the build such that it can get the output from the build and say, okay, I can confirm it succeeded. Here in a second, that should come up. I'm trying to remember exactly what the timeline is in the demo. So here you can see the time, or the tests were actually added. Yeah, and so here you can see it. It's really small again, but it's building code with the CMake tools extension, and you see the changes that are happening here. And so the tests were run. You can see the output here, and it actually was able to find, oh, the test failed. We did something wrong, or we maybe need to fix our code because the test we wrote was correct. Maybe you can never know exactly what's going on. I'm not sure what this project is based on, but now it actually edited it again, ran the build again, and is now retesting. You can see the build happening here, and then it will run the tests right after, all through our actual extension. And this can provide much more concrete ways to know how to reliably run the build and test tools. And so then it was able to make those changes. The tests run successfully, and then it fixes and says we were able to fix the bug and confirm that build and tests worked. Another thing to keep in mind here for why these tools are useful, specifically in the developer tool space, is there's a lot of different ways you can build your code. I'm sure many of you have built your code like through the command line directly and stuff like that. But especially with kind of AI in play, that's a lot more unreliable, or at least less reliable. So you can imagine the agent having to try and figure out like, oh, what flags do you want to use? What kind of parameters do you want to pass to your build? And having to do this all in this command line. AI's gotten pretty good at it, but we can actually do better because we can provide these tools through our extension that we already know everything about your build system. We can actually just run the build natively, and you can just rely on us to do that. So that's another thing that I've worked on for that. You got a sneak peek a second ago, but one thing that I also think is important to keep in mind is the mental load of using AI, especially in the developer workflow. It's really easy to kind of hear me talk about agents and hear me talking about all these things that it can do and want to kick off a bunch of stuff and do that. But there is a real mental load that you get when you use AI, or at least when you attempt to really go crazy with using it. And so the human brain isn't designed to multitask. And so this can make it difficult to keep track of different workflows. There are ways to have the agent run on autopilot. But one thing that, again, I'll reference Ben's slides, talks about is the lethal trifecta, which is a term coined when you basically have ability to access sensitive information as well as like reach out to the cloud and all these different things. And so it's often not recommended to run it in autopilot. You want it to ask you for permission to run these certain tools. So you can imagine if I have, let's just, for example, say I have 10 workflows running and all of them continually are pinging me saying, can I run this tool? Can I run this tool? That gets really anxiety inducing and really can be overloading for you as you work. And additionally, the increase of productivity that is possible with AI can cause kind of raised expectations and trying to do way too many things at once. You kind of know that you can be more productive, but then the question becomes how, and then you start really kind of spinning your wheels trying to get all these things to happen, and you kind of lose focus on what the actual task you're trying to solve is. But some reflections and advice. So one big question that I think is important to consider with a lot of this AI stuff is, this question kind of comes up for people a lot. Will AI take my job? And in my opinion, the answer is no, but a couple of reasons why. AI at its core, even when it gets really, really good, is still just token prediction. And so even with the advancement of models and things like that, it still needs token prediction, and therefore it needs context from the tools that we can provide or might already have. And so we need to be able to control that context, control that information, and also validate the output. Additionally, there is still the reality that AI can hallucinate and produce bad code and things like that. You might have had opinions recently of like products maybe degrading or improving, depending on how well people are making sure that it's producing good, valid output. Additionally, product owners and experts are always necessary. I think especially a lot of people working here are experts in their field or know a lot about their field, and that's always going to be necessary. We can't just rely on the AI to know that information. And then also there will always be a need for human connection required to be able to create tools and products, because at the end of the day, we are creating tools for other humans, and so we need them to be able to have good products that we know are usable. And then lastly, so just some advice on this question is just to continue to learn and build. As AI helps us be more productive, you still need to cultivate your own learning and knowledge, even while the AI is helping you do it faster. So for example, I know there's been many a time where I've been able to have AI really help speed up me writing my code or even write some of it for me. But I would just advise you to still build it yourself, or at the very least, spend the extra little bit of time to make sure you understood what happened, and could maybe write it yourself if you were asked to. Like I said, domain knowledge, design principles, et cetera, are still going to be crucial, even if you're not the one explicitly writing that piece of code. And then the driver and maintainer of the code is still you. And so you're still going to be, from a practical point of view, you're still going to be the one responsible. So if there's a bug, it's not going to be AI's name on it. It's going to be ours. And so we still need to know exactly what's happening there. Then some more general advice. I've been working close to 5 years, and a lot of that, if not all, for the most part, has been remote. So just a couple hints on remote work is that you need to initiate connection and mentorship. It doesn't just kind of fall in your lap. I think when I was early on in career, I felt like, I've gotten promoted, I've done well. Like, mentorship. Like who needs that? Like that's really crucial, not only for the sake of mentorship, but also just connection with everybody else and with others. And also take opportunities and seek out opportunities to network, especially working from home. It can be easy to kind of just stay there and stay in your shell, but it's really important to seek out those opportunities and go and meet people and create opportunities for yourself. Additionally, take ownership. Take ownership to craft excellence. So specifically, I think it's really easy, especially if you're working on like big products, it's really easy to kind of just do the bug fixes, do the features, and not really think too much about like making it your own. And part of that is being able to be creative and come up with new ideas to improve the product. And so really make it your own and don't feel like you're just building someone else's product. For me, like don't just kind of have this mindset, oh, I'm building products for Microsoft. Like, no, I'm the one working on them. How can I make it not necessarily my own, but how can I come up with stuff and kind of add my own touch to it by creating things that are great. And lastly, like I said earlier, don't just consume, learn with the knowledge or learn with the intent to teach. I think that's honestly really important when it comes to learning. And again, it not only contributes to your community, but it solidifies your own understanding. So that's just a couple of different general advice points that I'd like to share. So with that, that's all I've got. Thank you very much. And then a quick shout out before we all clap. My wife really helped me make these slides look pretty. She claims I'm an engineer that's not a business person that can't make slides look nice. So credit to her as well. So thank y'all.